Good morning, everyone. My name is S. Lokeshwar Reddy from the Department of Computer Science and Engineering, and today I will be presenting a seminar topic on separation of liquid mixtures. Let's see introduction of separation of liquid mixtures. Separation of liquid mixtures is a very important process in chemistry. It involves in separating the different liquids. Common methods used different in boiling points, solubility, volatility, or particle size. These properties may boiling point, solubility, volatility, or particle size. Such separation technique are widely used in chemistry laboratories, various industries, petroleum refining, and parametrical manufacturing. Each method is based on the nature of the mixture and the difference in the physical properties. Let's see type of liquid mixtures. Liquid mixtures can be divided into two major categories. Homogeneous mixtures. These mixtures have components that are commonly uniformly mixed. An example is alcohol and water. You cannot distinguish one component from the other by looking at it. Heterogeneous mixture. These mixtures have components that are uniformly ununiformly mixed. A common example is oil and water, which is from two separate layers. The type of mixtures determines which separation technique is most suitable. Simple distillation. Simple distillation is used when the difference in the boiling points of the liquid is greater than 25 degrees Celsius. In this method, we heat the mixture, the component with the lower boiling point, vaporize first, then it is considered back into liquid from and collected separately. Next, fractional distillation. Fractional distillation is used when the boiling difference is less than 25 degrees Celsius. It uses a fractionizing column which provides repeated cycles of vaporized and condensation. Because of these cycles, even liquid with close boiling points can be separated effectively. This method is very important in crude oil refining, where petrol, diesel, kerosene, and other fractions are separated. It is also used in separating nitrogen and oxygen from liquid air. Steam distillation. Steam distillation is suitable for liquids that are heat sensitive or have very high boiling points. When steam is introduced into the mixture, it lowers the boiling point, allowing the components to vaporize without decomposition. This method is widely used for extract essential oils from plants such as equivalently or lemongrass oil. Vacuum distillation. Vacuum distillation is used when certain components would decompose if held to their normal boiling points. By reducing the pressure, the boiling point of the liquid becomes lower, allowing distillation at a safer temperature. This technique is commonly used in the petroleum industry and for the purification of glycerin. Let's see azeotropic distillation. Some mixtures from what are known as azotropes, which are constant boiling mixtures that cannot be separated by a regular distillation. In such cases, an entrainer or additional substance is added to break the azotropes. One of the best example is the dehydration of ethanol, where azeotropic distillation is required to remove the last portion of water. Solvent extraction. Solvent extraction depends on the different solubilities of components in two immiscible liquids. A second solvent is added and one component dissolves more in the new solvent, allowing for separation. This method is used in parametrical extraction and metal purification. Next, chromatographic techniques. Chromatographic techniques are needed for very complex mixtures where high purity is required. Liquid chromatography separates components based on the polarity, adsorption, and molecular affinity. These techniques are widely used in drug analysis, biochemical research, and forensic studies. Decantation and separating funnel. For heterogeneous mixtures like oil and water, decantating of or a separate funnel is used when the mixture is placed in a separating funnel. The heavier liquid settles at the bottom and is released first. This is a simple, quick, and effective method for immiscible liquids with large density differentiation. Evaporation. Evaporation is used when the goal is to obtain the solute from solution. The solvent evaporation upon heating leveling behind the solid reside. A common application is obtaining salt from seawater. Application of liquid separation. Liquid separation techniques are essential in many fields including industrial purification process, petroleum refining and fuel production, paramedical extraction and drug purification, food and beverage industry such as alcohol production and flavor extraction. Finally, the conclusion. To conclude, the separation of liquid mixtures is based on important physical properties like boiling point, solubility, volatility, and stability. The techniques range from stability, simple distillation to highly advanced chromatography. These methods play a vital role in laboratory research, industrial operations, and environmental application. Thank you for listening.